Hello and welcome to another video on Newton's second law of motion. In the previous video we have defined Newton's second law of motion and looked at some cases, and now we will do an example. So once again, Newton's second law is when a resultant force is exerted on an object, it causes it to accelerate. The acceleration is directly proportional to the resultant force and inversely proportional to the mass. So we have this equation that F net is equal to m times a, where m is the mass measured in kilograms and a is acceleration measured in meters per second squared. Okay, so let us look at an example. Here is a exemplar question for grade 11s. So it says a skier of mass 60 kilograms skis from rest down a slope at an angle of 15 degrees. The length of the inclination is 75 meters. He reaches the end of the incline at a velocity of 15 meters per second, and there's a constant frictional force that acts on the skier on his way down. So let's look at the question. 2.1 is write down an expression for the magnitude of the normal force acting on the skier and then calculate its magnitude. Then draw a labeled free body diagram of all the forces acting on the skier as he skis down the slope. And lastly, it says calculate the average frictional force acting on the skier during his motion down the incline. Now, I'm going to start with the second question because a free body diagram always helps us understand the situation. So I'm just going to draw in the incline, just so we have it. Okay, so what forces are acting on the object? Okay, so first of all, on any object that's on Earth, we always have the gravitational. Now, I'm going to draw it using a dotted line, okay, because what I prefer to write instead of the gravitational force is its components. So the gravitational force on a slope has two components, F parallel, because it is parallel to the slope, and F perpendicular, because it is perpendicular to the slope. What other forces do we have acting on the object? Well, we have a normal force, and the normal force is equal but opposite to the perpendicular component as the object is not moving up and down. And as they've said in the question, we have some sort of frictional force denoted Fk. So that is our free body diagram, and now we will be able to answer the second question much easier. The first question. So just a little note, you're either drawing the gravitational force or its components. Please do not draw both, because then you'll be drawing the same thing twice. Okay, so we would like to know what is the normal force. And we can see by this diagram that the normal is equal to the perpendicular component, but in the opposite direction. So to calculate it, we're going to calculate the parallel component, which is Fg cos of theta, where Fg is our gravitational force, so it's m times g cos of theta, where g is your gravitational acceleration. So this is 60 times 9.8, and cos and theta is the angle of our slope. So typing that into our calculator, we have 567.96 newtons. Okay, that was pretty simple. So let's just label that's 2.2. And this here is 2.1. And now let's do 2.3. It says calculate the average frictional force. Now, we know how to calculate the parallel component, but we don't know what the frictional force is. Now, this is an application of Newton's second law. And what Newton's second law will allow us to calculate is the net force. So, we know that the net force, F net, is the sum of the forces on the same plane. So it's F parallel plus our kinetic force. So we will use Newton's second law to get our net force and then use that to calculate the frictional force. Okay, so let's start by writing down what we're given. That always helps. So we were given the initial velocity because it said rest. We were given the final velocity, and we were given the displacement. So let's write those in. So we were given initial velocity is 0 meters per second because it said it was at rest. We have the final velocity being 15 meters per second, and then it moved a displacement of 75 meters down the slope, and we would like to find out the acceleration. So what we then do is look at our motion equations, our formula sheet, and find a formula that uses these things. And the one that works is Vf squared is equal to Vi squared plus 2a delta x. Then we just substitute and solve. So we have 15 squared is equal to 0 squared plus 2 times 75 times a. So 15 squared is 225. 150a, divide both sides by 150, and we get the acceleration being 1.5 meters per second squared. Okay, so now that we have the acceleration, we can apply Newton's second law and get the net force. So the net force is equal to m times a, where m is the mass, and once again it was 60 kilograms and 1.5. So we multiply that, and we get that the net force is 90 newtons. And this is in the downwards direction. So we're going to take downwards down the slope as positive. Okay, so all that's left is then to use this relationship to calculate the one that we would like. So remember that Newton's second law does not calculate whatever force you want, but specifically the net force. And what is the net force? It's the sum of the forces on the same plane, which in that case will allow us to calculate the frictional force. So let us move on. So F net is equal to F parallel plus F, the frictional force. So I'm taking downwards down the slope as positive, so this will be 90 is equal to F parallel, okay, that's mg sine theta. From our previous video you can look at that. So that's 60 times 9.8 times sine of 15. That will give us, so 60 times 9.8 times sine of 15 gives us 152, and this is positive because it's down the slope, 19 plus the frictional force, and then we just solve, and the frictional force is going to be 90 minus 152, so it is minus 62.19 newtons, and the negative tells us that it's in the opposite direction as what we took up, so it's 162.19 newtons up the slope. Okay, so this is the typical answer, a typical kind of question that you would get, and this is how you solve it. You break it down, draw the free body diagrams, and remember what calculates what. Please remember to write your units and be clear in the way you answer your questions. So there's our question once again, and what we were answering was a question on Newton's second law of motion. Thank you for watching. Please like, subscribe, and comment on what type of questions you'd like to see and what type of work you'd like me to do. Thank you so much for watching. Bye.